We were discussing propositional equivalences when we stopped last time. Now what I want to do is I want to go over an exercise that's similar to the exercises that are assigned for this section 1.3, propositional equivalences. So exercise 4 is use a truth table to verify the associative law. The quantity P or Q or R is equivalent to P or the quantity Q or R. So the first question is, how many rows are needed? The answer is, we need 9 rows, 8 rows for the truth values of P, Q, and R because there are 3 propositional variables, so 2 cubed is 8, plus 1 more row for the title row. How many columns do we need? Let's develop the truth table a step at a time. First, we need a column for each of the propositional variables, P, Q, and R. Step 3. Now we need to populate the rows for the columns labeled P through P, Q, and R. Alternate trues and falses in the R column, the rightmost column. We see true, false, true, false. Next, move to proceed to alternate trues and falses for the Q and P columns, but have the frequency as you move to the left. So we can see in the Q column that we have 2 trues and 2 falses, and repeat it again for the remaining 4 values. And in the P column, we have 4 trues and 4 falses, so that the frequency is halved as we move to each succeeding row moving to the left. Now make a column for the first operation, P or Q. Compute P or Q for every row. And P or Q is true for every row except the last 2 rows where both P and Q are false. Now make a column for the second operation, P or Q or R. We proceed to populate that for every row, and we find that only the last row is false. Now we have computed all the truth values for the left side of the equivalence. Now we must consider what to do next. 2 expressions are equivalent if their biconditional values are true for every value of the propositional variables. Now make a column to the right of the original expression, but substitution the biconditional operator for the equivalence operator. So you can see that what we have is quantity P or Q or R, if and only if P or the quantity Q or R. Make 2 more columns. The rightmost column is labeled Q or R, and the column between the rightmost column and the biconditional column is labeled P or the quantity Q or R. Complete the rightmost column, which we see is we have 3 trues and a false, and 3 more trues and a false. Complete the column P or the quantity Q or R, where we see that we have all but the bottom row is false. Then what we do is we perform the biconditional operator and compare each the value in each row to see if it's the same, and we find that it is the same. If every value in the biconditional row column is true, then the 2 compound propositions are equivalent. Add an additional row, forming the conclusion that we just stated. The quantity P or Q or R is equivalent to P or the quantity Q or R because both compound propositions yield a value of true for every combination of P, Q, and R. For the purpose of submitting an assignment, we need only submit the finished table as shown in step 14 above.